Okay. And that's actually potentially someone I should subscribe to. I mean, follow. Who is that? Oh, it's a YouTube stream. I streamed 3 hours ago. Okay. Failing at Game Dev 3. Keep an eye out for that person. Okay. Render to images as targets. Turns out this is called a render target. Turns out that makes quite a bit of sense as a name for something that renders to a target. How does this all work? Let's stumble around in the dark a bit and find out. Okay. Now then, what I think we need is a very simple example driver. This is always what we do when we just can't understand anything. When things don't make sense, this is what we do. So let's try to do that. Maybe if we take the render target example, the 3D one, and just create a 2D version of it. Can't remember what it's called. Render to texture, I think. It's under 3D, but we can create a new version of it. So we'll grab that, and then we will go to a new directory. Cargo new render target example. In main, we will do this. And then we will go cargo add bevy. And then we will go like so. And then we will see if that works. Once Rust Analyzer figures out everything. You can do it, Rust Analyzer. I believe. I believe in you. You can make the thing happen. It's running Clippy on every part of Bevy. Okay, let's try running that. Come on, Clippy. Let go of your lock. It's okay to let go. It's okay. It's going to be okay. Clippy, you can do it. Let go. There we go. Okay, so this is rendered to texture. Interesting. Interesting. All right, so let's turn this into a 2D example if we can. Make this a little bit more realistic. Well, smaller anyway. I'm fine with basically everything being default here, but this I think would be better as I think it's R8 S norm SIGB, something like that. I wonder if the texture format was different in the other example. I think it was RGBA 8 UNORM. Actually, let's just look it up. Why are we guessing? Why are we guessing? Why are we guessing that was the wrong one? No, that's still the wrong one. I used I used the existing texture, so I didn't even specify it. Right. So we loaded it basically. Blue, green, red, and alpha channels. Sure, why not? We'll leave it that way for now. Then we got set these texture usage flags in order to use the image as a render target. Yes. In fact, let's keep that other buffer available. I used copy DST, copy source, texture binding, render attachment. So I think we'll add texture usages, copy source. But we're not going to do okay. There is an extent 3D for 2D images. All right. We're not going to display a cube. We are going to use a custom material. We're not going to use a mask or anything complicated like that. We're just going to label this texture, and this is going to be a color. So keep it real simple. Why haven't I got my attributes? What's going on here? As bind group is also required. We're going to need shader ref in a minute. Okay. Now, we're also going to use this. We're not going to use cubes. And we'll bring across the shader just to use as starting point. Copy previous directory. And we'll move that into assets, color shader, which I object to the spelling of, but I'll do it anyway. This is a color, and it's a vec4. This is just called texture. It's called texture sampler, and that doesn't exist. Vertex output is fine. And we'll return color. So the simplest possible shader we could possibly imagine. Then we'll get an image from Aspirate. I think we said 256. And we'll make it, I don't know, green. And we'll export as. We will export as. What are we calling this? Render target example? Asset, yeah, assets and green PNG. Cool. Then we'll go. Prefer init to setup. Don't ask me why. Okay, resume assets mesh, no, but images, yes. Standard material, where no, it's going to be material 2D, I think. Oh no, we're going to use custom material. So is there any initialization that has to take place for level material to be a thing? We need to init resource render target. So this is going to be render target like so. Oh no, we can't use that name. I guess image render target, for want of a better word. So we've done that. And then add plugins, material 2D plugin, level material defaults. Well, it's going to be custom material. And then we'll grab the implementation for material 2D. Nice. I don't think we need to care about alpha mode blend right now. We just need the shader F. Okay, so we have render layers layer 1. We're going to put that directly in. We're going to spawn. I want two things. I want, it's kind of like I want to render to the camera, but I also want to render to an image. That makes no sense. I want to be able to display the blended kind of output of the GPU, but I also want to render it to an image so that I can use that on the CPU side. Does that make sense? Maybe that doesn't make any sense. I want to store the output as an image, like saving the image almost. Yeah. So I need to ensure that that's happening. So the goal in this example is just to render the image and not also display the output to somewhere else. Okay, let's look at our spawning here. We've got two cameras, one for the render target and one for everything else. So camera with a target and image handle flown into a render target. We'll put the clear color. I don't think it'll matter, but maybe that'll help us debug. And then the default. And we'll get rid of mesh 2D. We'll use the default there. And we'll go render layers, layer 1. What's your deal here? Oh, yeah. Okay. We don't need a light. And then we want a regular camera as well, I think. So main camera. Use required components to pull in camera, I think. And then it'll be the default render layers. This material has the texture that has been rendered. So what if we have two material 2Ds? One, the custom material has the shader attached to it. And the other, and then we're just displaying a sprite that has the image on it. Because that's essentially what we're doing in the game. So let's try and duplicate some of that without reintroducing the complexity by accident. I don't know about the transform. We'll see. And texture handle should be image handle. And yeah, there's the main pass camera. Okay, cool. So we've got two cameras. And then we're going to have um, one custom material and one just sprite, basically. Okay, so let's go with this. Those are our cameras. And then we'll spawn custom, mesh, basically, with custom material. And this is going to be tagged with something probably, but let's not do it right now. Mesh 2D, meshes add, rectangle new, 256, 256. Mesh material 2D, materials add, custom material. And then a color, which is going to be, I don't know, red or black or something. Black. Oh, maybe don't need the into. Need an SIGBA from. This is going to be an asset server load green PNG, which means we need asset server. And we need meshes. Res mute assets mesh 2D, I think. Oh, just mesh? Or mesh material. Hang on, I'm completely lost now. No, just assets mesh. And then this is wrong. Yeah, so I guess it should be color sRGBA from or something like that. Like that. Is there an into or am I doing this wrong? Oh dear. Honestly, I could just specify it. Is there an ASVEC or like a, how do you get a VEC4 from an sRGBA? Honestly, let's just specify it. Will that do the trick? Yeah. Okay, let's give that a crack. Oh, and we need to take this off. So the render layers thing, it should default to 0, I think. That's the main pass. But I may still need to dive into this a little bit more to understand what's going on. So our theory is that if we run this, we get, oh, let's get rid of all this cube rotation thing. Okay, how many errors do we still have? Okay, we're good. All right. So let's review. We've got an image which is just created. Actually, we don't need that anymore. What we need to do is take the image that we loaded. Oh, wait, yes, we do. Yes, we do. This is our target image, not the source image. And actually, it's being filled with zeros. So it's transparent currently because the alpha is 0, I think. This may not be correct. But yeah, we've got a target image and we're saying that you should copy source. We're saying texture binding, which is allows a texture to be a binding type texture in a bind group. Sure, so it's usable in the GPU. We're saying copy destination. And we're saying it's a render attachment. So it's an output target. And we're adding it to images. Then we've got 2 cameras, one for the image render target, which is, actually, hang on. Are we even using that resource? We're not at the moment. The, this resource, but we will. In fact, let's do that here. Target image. Hey, oh, hang on a sec. I'll be right back. You know what? There's hard times all over, folks. There's hard times all over. All right. So if we have a target image resource, we'll add it here. And we will texture equals image handle clone, just so that we're storing the image handle somewhere, remembering it on the CPU side. Okay. So I actually have no idea what happens if we run this right now. We've got the custom material, which has a rectangle 256, 256. And we've got the ordinary sprite, which has a size of 256, and we've added a transform and a scale. I have no idea where that's going to end up positioning, but let's find out. It even runs. Okay, so we've got a black square, and we know that it's being based on a green square. What we don't seem to have is the other sprite, and that may be because of the transform. Let's find that out. Let's make this a lot less severe. And we'll make it half the size. Give that a crack. Oh yeah, there we go. Okay, interesting. So what we're seeing here is the white whatchamacallit, what do we call that thing? Clear color. We're seeing the clear color, which is the background color. If I don't have that there, I'm pretty sure we'll see nothing. Yeah. Okay. So let's put that there just so that we know what we would expect to see is the render layers 1 stuff. So do we have that on the sprite? Ah, we don't. Okay, let's do that. So the camera seeing this should, in theory, we should see two black squares side by side. We do not. Okay, so that's my first problem. Why don't we? So we're rendering to an image. We're displaying that image on a sprite just for the hell of it. And we're giving it a transform. We've set the render layers to the right thing, I think. You're going to lurky McLurk my face. That's not how the saying goes. But thank you for the lurk. I hope you haven't been up for 24 hours again. Okay, so it's Lucky McLurkface. And you know why? It's because there's an item in Bevy called Tony Mc map face. Tone map method, tonemic map face. I'm not kidding. This exists. This is a thing. You've got to do your ESL help work today. ESL is English as a second language. Okay, so if I display it as render layers layer 1, it's invisible. If I display it as render layers layer 0, it's visible, but the rendered image does not appear. And if I give it both layers, it'll display as black. I have conversation with people and correct their mistakes. That's kind of cool. You're like a only for English instead of something ridiculous like this. English is actually a lot less predictable than Rust. Okay. All right. So it's invisible if we're in render layers 1. I'm not sure why. Because, I mean, does the image still exist? The image exists, but does it have... See, I think what's going on is this is transparent. If I do that, what happens? Still nothing. So returning, it should be rendering a sprite that's black. I think that's my ridiculously untutored understanding of the situation. Let's do some more docs reading and see if we can understand it better. English is pretty predictable. I don't know. I've talked to people like German speakers who follow a pretty strict set of rules and they think English is ridiculous. But then I think German is ridiculous. There's too many genders and tenses. I tried to learn German in high school. It was not a success. I don't know why they wanted us to learn German. All right, let's look at render layers. Describes which rendering layers an entity belongs to. Cameras with this component will only render entities with intersecting layers. Entities may belong to one or more layers or no layer at all. The default instance contains layer 0. Entities without this component belong to layer 0. So what if we put sprite on the second render layer as well? I mean, yeah, the second render layer, but not the camera. Wait, which file is this? Oh yeah, so debug image render target. I have copied, oh hey, Death Rat. I have copy DST and copy source both on the source image. You probably just want copy source and then copy DST goes on a target image. Okay. Thank you. Let me try that. On the source image. Actually, I think that's the target image, isn't it? This one right here. This is the target. But copy DST goes on there. So let's get rid of this, which I did add. Um, I don't even specify what goes on the source image. It's just an image. Maybe I should specify something. Both on the one, yeah. So it shouldn't like it just go back and forth. Maybe so. Let's just see what's going on there with that change. Okay, so still empty. So this is the custom material, and I'm hoping to get I presume if I add the sprite, where's the sprite? Where's the sprite? This one. I presume if I add this to render layers, both, that I'll get something, but I don't know if it's what I expect. Okay, so that brings our white square back presumably because the main camera can see it now. That's my interpretation. But if I take away the clear color, it's just not there at all. And just to confirm, my shader is just returning the color. So it should just return black because that's all I'm passing it. 0001. Having said that, I have provided a texture format of this. I don't know that that's necessarily right, but alpha is still the last value, right? What's the default? Does it have a default? No. What's the base? What's the norm? What's the normal one? R8 unorm? I mean, what do most people use? Confusing. It depends on your use cases. Okay. Well, that was one example, so we'll continue with that, although it was a 3D example. Interesting. So I can add it to both layers. I can add the sprite, which contains the image render target, to both layers and have it be visible, but not have it show up with its image content. In fact, it appears to be transparent to all intents and purposes. Do I need to put it on a mesh? Is it the fact that it's a sprite and not a mesh? What happens if we change that? Let's try. I can't imagine it would make much difference, but it might. Do I have the render layer on my camera? Yeah, so we've got two cameras. We have the one for the render target, which is rendered as 1. And then we have just a regular camera, which is obviously render layer 0. And the shader is successfully turning a green image into a black image, which is what it's supposed to do. but for some reason, you think it should work on a sprite? I'm sure it probably should. I'm just playing around at this point. Um, so we could do mesh material, add color material with the image. Yeah, no, it should work on a sprite. You're right. I'm being dumb. Hmm. So what am I not doing? I can get it to. Do I set a priority for my camera? I did not know that was a thing. What are the fields on camera that I need to know about? Mm, that might have been removed. Maybe. Nope. It was renamed to order. Yeah, that makes sense. So let's go. Oh, yeah, order eye size. Cameras with a higher order are rendered later and thus on top of lower order cameras. Okay. So hmm, the thing is, even if they were the wrong priority, wouldn't you expect that they would both eventually display? You realize why it's called Rust because it's the opposite of sleek, clean, and shiny. Hey, don't be rude. Uh, okay, so let's just play with priority anyway. Where are we? We're in the wrong file. So let's go with order. I don't know. 1. And then you get the, it's completely fine. I'm just having you on. Wait, what is the default? Eye size. The default for an eye size has got to be 0, right? Uh, so if we give it a later priority, it should render on top, you would think. Higher order for the render target, yeah. Yeah, let's crack on, Hell, why not make it 10? Okay. Ah! Oh no, we knew that was going to happen because the clear color is there. But it's still not, I would still expect it to be black. And if I remove the clear color, I mean, the clear color should always be overwritten by the image anyway, right? So, yeah, and if you take the clear color away, it just doesn't display at all. Actually, I'm going to set a window config so that this stops showing up in an i3 split. Oh, I always forget this. Oh my God, so many files. Window plugin, primary window. Resizable false. What is your problem? Did I use the wrong window? Default plugin set, window plugin. Oh, into, right. Okay. Your opacity is O though. Oh, really? Don't tell me I've been missing something all along. Where the hell am I? I think my opacity is at 1. Or the opacity for this is at 0, but after it's been rendered to it should be 1, right? The alpha. Because we got, it's rendering this color, which is black with an alpha of 1, unless I'm wildly mistaken. Which I could be, because let's face it, that's my normal state. So yeah, we're just getting the 1. I'm going to stop scaling it for one thing, and I'm going to give them both a transform. So we see them side by side. Where am I? I am here. Yeah, so we're expecting that. And if we add the clear color back in, we get them side by side. Okay. Interesting. So we're successfully rendering. I think the difference between this and some of the other examples is that this one uses a custom material. And I just wonder if maybe there's something in specialized for the custom material implementation. Maybe I need this, but I don't know exactly what to put in it. Maybe I need to change something about that. You don't think I do? It's confusing me that I understand that cameras are used to set to do the render target. Hey Corey, how you doing? But yeah, I'm just not quite sure why the image isn't showing up. It's in the main world. We know that because render asset usages is main world render world for both, for the default. Is it because I'm doing it in startup and it hasn't had time? But no, it should show up in the next render pass. Did you figure that thing out? That would be for attaching different data to the vertex attributes. I gotcha. No, I didn't figure that thing out. I figured out how to use masks. So for context, this is this is kind of the goal, is that we have, this is the preview image of what I'm trying to get to render, but actually it's the level material right now. So we've got this mechanism whereby we can blend a circular mask image with the terrain image and have it render to the main view. But it's not altering the terrain image, which is what we need in order to do collision detection. And that's the problematic part for me. So I was thinking in my head, hey, what if I render to a target image and use that image as my source of truth, right, for doing things like collision detection? But turns out that's not so simple. So this is actually the level material or the custom material. But if I change it to be just the sprite, um, mm, 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 it's not that much more complex than my example, but it's just enough that I wanted to try and dumb it down a bit to see if my brain could get it through its head. We should consider taking that copy DST out, like it was saying, or the copy source. Oh, we got ads running through. Just going to make a quick cover. Okay. Cup of tea enabled. Oh, no ads for you. That's good. I hate the ads. I just do it to stop the pre-rolls. And also because it's a nice punctuation. Like it kind of almost forces you to go and make a cup of tea, which is good. Get up and stretch a bit. Okay. So, yeah, so we were looking at the original, which is the game version of this. Welcome back and thank you. Um, and the only reason that an image is showing up is because I've got the level material on both layers. And I shouldn't because that doesn't make any sense. Definitely get rid of copy source from that. Gotcha. um, yeah, I think it was kind of spamming everything that I could at it. This should be actually the default uh, render layer because this is just the custom material. Custom materials is the missing link here. Um, so yeah, we should kill that because it's what stands out from the other examples. I haven't yet found an example of someone doing render target with a custom material. I should try and track that down. Um, so if I take away that render layers, that leaves us with render layers 1 on the render target camera and hopefully on the debug image. It isn't at the moment, but let's try here. And then the image is just absent entirely. So yeah, that's kind of the same behavior, but I just wanted to revisit that. Do I have clear color on this? Yes. So yeah, very similar setup. Let's go back to the red target example. So yeah, in theory, oh, did we just die? What happened here? Wait, what? Oh, I'm still in the wrong file. In theory, I should be looking at 2 black squares. The one on the right is a green square that's being changed to black using a GPU shader, just fine, a fragment shader, if you will. And the one on the left should be an image that's being rendered to as the render target. I think, maybe. The image exists, but the camera is just showing its clear color instead. Do I insert the image? I do, right? Starting to second guess myself now. Yeah, images add image right there. And I also copy its texture to a resource, but that's incidental at this point. The idea being, of course, that you can create a system later that would retrieve the image and go over it or use it for on the CPU side. The alternative, of course, is to do that kind of thing in the GPU using a, what am I filling into the render target? What am I filling into it? Oh, this, you mean? Sorry, this might be a little small. Tell me if that's the case. Go up to. It's what you call community debugging. um, yeah, I could potentially do uh, GPU collision detection, but I'm just really curious about why this doesn't work. I'm kind of hooked now. I need to know. And maybe it's not supposed to work. Maybe I'm doing something that it wasn't designed for. What am I rendering into the render target? Well, maybe that's the missing step. But I thought if I use a custom material that has a shader attached to it, and the shader is literally this, returning a set color for every pixel. I thought that if I did that, but specified it using the camera, specified the render target. Actually, maybe that's not what I'm doing. Maybe I'm completely full of shit. This doesn't do what I think it does, I think is the problem. The target that this camera will render to, but how does the shader from the custom material, maybe that custom material has to be on this camera kind of thing, or this render layer. You're rendering the contents of that image, but that image isn't being changed by anything. Yeah. See, I think that's the problem. What I actually want is a pipeline that renders the output to an image, which I thought people used for, like, for example, if you had a graphics program and you wanted to save the image, you would have to render it to an image, right? And that's kind of what was in my head when I was thinking, hey, how do I get this mask and this background image rendered to a set image so that I can save it or use it? But I think I'm getting my concepts a little mixed up. So this is good. This is healthy because now we can try and figure this out. Um, I just like to see it working or understand how that works. And I thought render layers was kind of the secret, but I don't think it is. I think I'm misunderstanding that. Um, for example, if the custom material and render layers were all, if the custom material and the camera and the sprite were all on the same layer, it would work. But I don't think the image would be changed. But maybe I need to determine that. You need to render something to the same layer. Right. So what we need to do to prove it is to have a system that detects if the image is green or black, basically. Um, so we need the image to be changed in a material way. Let's go, let's debug this. Let's go check image. Let's be in the middle, yeah. Check image. So we're going to need images, res, assets, image. We're going to need the image handle, which is contained in render target, which is a res image render target. I could render like a sprite to that layer and color it green. Yeah. So we're already, I think we're already outputting a black image to the screen, but we need to output it to our image. So we need to prove whatever the color is of this image is changing, basically. So let's try this. Let's try and then with that image with the render target, we'll have a flat contents of that render. Exactly, yeah. So merging down everything. So let let sum, let okay image equals images get render target texture That's going to need to be a reference, else return. And then what is your problem? It's an option. I always get that mixed up. That is not used. Okay, so now we just do something with image. Like we need to determine what its colors are, or what its first pixel is, or something like that. You do have some recursion, I think, in the sprite you have with the render target on is in both layers. Yeah. So that was just to get something to show up, but I think you're absolutely right. So let's go like that. Whoops, wrong one. You would want a source layer and a target layer. Anything that should be in the render target would be in the source layer. See, I was starting to think that maybe the custom material should be in the render target layer, but because that's the state that we have now. We've got the custom material is in this what I think of as the source layer or the main layer, like render layer 0, right? And then the render target is in layer 1. I'm just going to take the order out of that camera just to remove any variable. So hang on, let's add a debugging step. So how do I get like the first pixel out of an image and display it? I think image has a data. So for example, debug image data, I think. Data is evacuate, yeah. Let pixel equals image data first or iter first, something like that. Or can you even do this? How lame is this? I'll let you go through your thoughts. Yeah. I might want 3 layers. Yeah, I don't know if my brain's ready for 3 layers. Debug pixel. Okay, and then we'll go add systems, update. What did we call it? Check pixel or check image. Ugh, I hate it when that auto completes like that. Okay. So with that in place, we've got the pixel is 0. What? I did not expect a single integer. Oh, because, right. So every 4, yes. Yep. Every 4 U8s. Oh, you're thinking as a UVEC3? Yeah. I gotcha. I don't think I need to. I think I just, since all of the pixels are being reset to a color, all I need to do is grab the first 4, right? Like literally, this is a dreadful way of doing it, but I think X, Y, and hang on, if it's each pixel should have 4 components, right? So the texture format will define the order, right? And it's B, G, R, A. So B, this is so bad, but I'm totally going to do it because I don't care. This is the mental model that I'm working with right now. I could easily be wrong. Let's experiment. Yeah, it's all 0. So that to me says that the image is not being modified because it starts at all zero. And we can prove that by altering the image contents like so. Yeah. So it's not being rendered to, at least not in any meaningful way that I can use. So let me take a swallow of tea here. So now we need to start messing around with the render layers, I think. I wonder if the two cameras business is actually screwing me over a little bit here. All right. Now we add the custom material to render layer 1. So we've got the image in render layers 1. I do, yeah, I think you're right about that. Well, the camera, this camera has render layer 0. This camera has render layer 1. That's correct. Well, that may be correct. The custom material has render layer 0 because that's the default. So now we add render layers layer 1. And the only thing we're interested in is whether the debug output changes. And it doesn't, except that now we don't see anything. But we're still not rendering to that image, at least not the way I would expect. So, what's the next step? I've got basically everything on. What happens if I strip out the render layers altogether and everything's just on the default? Well, the image isn't changing, but the screen is displaying. Huh. I think the reason. So it thinks that everything is 0 in the image. So there must be a step that I'm missing to get a custom material to render to an image. Unless I also could be misunderstanding this format. But I don't think I am. Mesh 2D needs to be on the layer. Okay. Well, we took away the layer. The layer's on, everything's on 0 at the moment. But let's redo a few things. Okay, so we've got render layers 1 on the render target camera that's targeting the image. We've got it on the custom material with the mesh 2D. And we've got it on the debug image, which is just a sprite. So that takes everything away from render layer 0, which is where the main camera is. But it also shows that there's absolutely no change to the image, unless I'm misunderstanding that too, but I don't think I am. Hmm. Interesting. The cameras are here. So we've got um, a camera 2D with a target, and then we've got just a regular default camera. I wonder what the default for target is. It's probably window, right? Hmm. Let's have a little squiz through the Bevy examples for more render target stuff. Oh, what am I doing? Bevy. That's just setting the monitor and multiple windows. Render target image. Render resource. Let's have a quick look at this one. Order -1. Hey, look at that. That's something new. Render before the main pass camera. Render target image, image handle clone into. But interestingly, it lets me not do that. So let's be explicit about that. No, not necessarily. I mean, I didn't even know order was a thing. So, um, but let's move along those lines. Maybe we want a lower order. Yeah, yeah, maybe so. I didn't even think about it being negative. But let's also just look at this target business, because image handle clone into I thought was working, but what they're doing is render target image like so. Useless conversion to the same type. Yeah. But it's the same thing. Um, so I don't know that that's correct. Yeah, render target has from image. I'm sure that's correct. But we will just test it. What I will do is check. They're not using a custom material, are they? They're using a canvas. What is high-res layers? Yeah, the order -1 could be interesting. Um, I'm just not sure where to leave my render layers at, but let's just run it as is. You don't think the custom material matters? Hope not. It might be a red herring. Okay, so that would be on the render target camera, which is here. Still much the same, but let's mess with the render layers now. In fact, do they even change render layers? Pixel perfect layers. What is that? Render layers O. High res layers. Render layers 1. What? Okay, so they've got the sprite is being rendered to the render layers 1. And then they've got a sprite rendered to, I believe I've used a custom material without anything special for render targets. Oh, I'd love it if you had some sample code. God damn. This is surprisingly difficult, but I'm pleased because I've really been wanting to get into understanding rendering and shaders in a bit more depth. So this is very good for me. It's just frustrating at the time. Pixel perfect layers, high res layers. Okay, so I don't find that abstraction terribly useful. I'd much rather just see the render layers thing, but never mind. And then, oh, well, they've got a custom material right here. Actually, not a color material, but, same, maybe. So that's going to render layers O. I wonder if it's the opposite. Maybe I should be putting the other one on render layers 1. Where was that order? Oh, the image is the canvas. I see. And they've got texture binding, copy DST, render attachment, BGRA 8, UNorm sRGB. Okay. This camera renders whatever is on pixel perfect layers to the canvas. Right, so whatever's on render layer 0. I see. Is the canvas on render layers 1? Yes, it is. Interesting. The outer camera renders whatever is on high res layers to the screen. Here, the canvas and one of the sample sprites will be rendered by this camera. So the inner camera is essentially the render target camera on render layers O. Where is that camera? Hello, camera. This camera. This renders to the canvas, which is an image. We should run this example. Pixel grid snap. Okay. Spawn the canvas, and then the outer camera renders the canvas to the screen, which is kind of, I don't know that I actually want to do that because I actually want to use the image for other reasons, like CPU reasons. But let's mess with this a little bit. So everything that's being rendered was on render layer 0. Canvas is a Bevy UI component. I see. Okay, let's run that. Yeah, the Bevy UI thing's slightly. Oh my goodness. Ha. Okay. Interesting. I don't entirely know what I'm looking at, but that's interesting. It should effectively work the same if you're doing a mesh 2D instead, right? So let's think about this. We've got a bunch of stuff happening on pixel perfect layers, which is render target 0. And then we spawn an image on render layers 1. And a camera with MSAA off on render layers 1. Where does it spawn the mesh? Does it spawn the mesh? Oh yeah, here. On render layer 0. Sample sprite rendered to the high-res outer world. Sample sprite rendered to the pixel-perfect canvas. Canvas equals mesh 2D in this example, right? So hang on. Now that I know what I'm looking at, that's why. So this is MSAA off, and this is, I guess, on. Well, this is on. Okay. Okay. This one is dark is being spawned on rendered layer 0. Light is being spawned on render layers 1. And that's on render layer 0. Okay. I think you just got to get your layers right. Yeah, I think you're probably right. I think I'm going to feel kind of silly once I eventually see it, but that's the way it works. Okay. So I think what it was saying was all of the things that from the source is render layer 0 and the destination is render layers 1. So we could try working in that direction. The render target camera, I think we will treat as render layer 0. And the main camera as render layers 1. Where's my main camera? There. Actually, I don't need that. So render target or source cam, question mark, main or destination cam. And then we've got our custom material, which is our source. On render layer 0. And our destination is our sprite, which in my estimation should be render layer 1. But in its mind, we're rendering to a image on a mesh. This image. And that is being placed on there, rendered layer 1. Render layer 1 for the sprite. Yeah, I think so too. which it already is. Okay, curious if that makes any sense. So we'll just play around with that for a minute. Interesting. It's compiled them both. Okay. And yet the image is still all zeros. What the fuck? Okay, so it's generated both of them into one composite view. And yet I can't use the pixels from it. God damn it. I wonder if I took these from the end of the array. End of the data, yeah. The camera reprojects, so if it's clipping the sprite. I wonder if I took them from here, whether I'd get black. Hmm. But it doesn't change the fact that it's not quite the image we're looking for. Just add a 1 in front of all the numbers. uh, oh god, it's cursed. It's wholly cursed. No, I can't do it anymore. I need to do it properly. We need image length basically. Let lan equals image data iter length, or do I have to use length? Can I do that? I can do that. Therefore, I can do. This is so bad. Let's see, -4 because it's non-inclusive. What did I say about doing it properly again? Oh, God. It's still all zeros. I genuinely think this is. Yeah, see, I don't think this is the image we need anyway. Like, if it was working, I would expect it to be black, but it's not. So I'm seeing what the first camera sees and what the second camera sees. Unless I completely miss my guess. Hmm. So this is the sprite. It's on render layer 1. This is the source custom material. So this should be destination image on a sprite. The destination camera is render layers 1. I think I want this organized into source and destination. I'm fascinated that it's come up with something different. I just don't understand it. So we're adding the image here. Check out the Bevy cheat book for render target books. I think I did yesterday actually, but I can't remember how up to date they were. Whoa, why did I go there? Has some helpful info to debugging. Oh, did he? No, I was going to say, did he sync this for retained render world, but he didn't. Oh, in the search. Camera renders to image asset with ID. And the viewport. Filter what entities should be drawn by what cameras. Insert this component to place them in specific layers. Selects what layers the camera should render. The entity will be rendered if there is any overlap between the camera's layers and the entity's layers. They have at least one layer in common. Top left of screen next to the list on the left. Oh, you mean this, yeah. If an entity does not have the render layers, it belongs to layer O. That's what I got from the docs. Renders everything, blah, blah, blah. The sprite will be seen by both cameras. Yeah. Debug viewports. In the camera ordering. What happens if I run it without the clear color? No, okay. No. Disable clearing, yeah. It just ends up with transparent, but I think it does. Well, let's make sure, but taken from the world's clear color, which I think is none. Okay. We can set it to none. Won't hurt. Yeah, much the same. Okay. So multiple cameras. Two passes, multiple layer passes to the same render target. Priority doesn't exist anymore. Disable clearing. Render layers and render to image, render to texture, which is what we're doing. If you want to generate an image in memory, output to an image asset, intermediate steps, rendering to a mini map, kind of what we're doing, or the gun in a shooter game. Another use case is windowless applications that want to generate image files. Yeah. So it's sort of what we're doing, but I'm missing something still. But it's certainly doesn't hurt to set the clear color off. The debug viewport stuff. I guess I missed that. Hang on. Oh, where am I? Oh, the area a camera renders to. Might be the positioning of the mesh 2D inside the render target camera. Yeah. We should also tag the cameras. So let's do that. And like so. Where's my other camera gone? Oh, wrong one. Try zeroing out the render textures, the render target's mesh transform. If it's not, then you can move the sprite that's rendering the target image instead. Try zeroing out the render target's mesh transform. If it's not, then you can move the render target mesh. I mean, I was just using the default originally, but so you think the transformers? Yeah, I was just doing that to put them side by side. The mesh that's supposed to be inside the render target. I see. Yeah, maybe I don't know. I just wanted them kind of next to each other, but hang on, let's try this. What? Wait a minute. I think you move the destination sprite instead of the one being sourced. I see. Yeah. I gotcha. Yeah, you're right. So maybe that's what we're looking at then. Since it shouldn't matter where this one is right now. Because the thing is, I don't even care if it's visible or not, if you know what I mean. Like the render target is supposed to be used by the CPU. So I don't even care that the sprite exists. I was using it as a debug facility, but it's interesting to me that now that we've taken that transform away, it behaves kind of the way I would expect. The only problem is that its data doesn't seem to be the way I would expect. But maybe I'm misunderstanding what that data should be. Hang on, let's play with that a little more. So, It's still all zeroed out. Gonna have some padding. I see. That's why the debug viewport is useful. All right, so you'd want to access the coordinates of the image relative to the viewport. Interesting. Okay, let's look into that. Because I think the fact that it's black now kind of fills me with hope. So let's see if, but the other problem is with that, hang on. The main camera is on render layers 1. The source camera is on render layers O. And so is the material. I'm just trying to make sure that I'm not accidentally looking at the material, but I'm not. At least I don't think I am. Oh, thanks for the follow, Org3. I appreciate it. Well, that's interesting. Why didn't I hear that sound? Is my... Yeah, the pixels you're accessing is just the first pixel in the top left of you. Oh, dude. Seriously? Because... why is my headphones not working? I did not hear a noise and I should have. Ah, there it goes. You want to convert between world space and pixel screen space, but hang on. I thought I was directly accessing the image's data. So it shouldn't really matter what coordinate versions I'm using, right? But let's mess with this some more because the fact that it's showing up as a black image now is encouraging. I just want to make sure I'm not somehow still seeing the custom material. The image is projected onto your screen because it's after rasterization. See, I would never have thought of that. Okay. Because I thought when you looked at the raw image data, that's what you were getting. Okay, so to do this, I need this stuff. So I need, this will possibly partly be wrong, but let's find out. So we should be able to do a cam single render camera with render target camera. The render to target is going through the whole render pipeline to split out what would otherwise be splitting out to your camera screen. Right. So this whole other, I see. So this would actually be easier to debug if the image was the same size as the screen, right? Like what we should be doing is something like a size up here. And yeah. Anyway, let's not mess with that right now. Let's figure this shit out. Oh, we got ads in a sec. Oh, we got ads now. I do apologize. Okay. What the hell? I think that might have changed names. Nope, still there. Interesting. Hmm. Restrict the viewport of the render target camera to the bounds of the source image. So on camera, on this camera, I presume it's rect. It's an option viewport. Yeah. Physical position UVEC, physical size UVEC. Does the other example do this? No. What have I got available on a viewport? Not much. uh, Physical position 00 corresponds within the render target of this camera. So you would expect that, oh, interesting. It's within the render target. And the render target is the image. So actually, this might not be relevant because the render target already has the bounds of the image, which I think is why we're seeing when we run, we're already seeing this rectangle as our viewport. Um, Interesting. I wonder if I'm misunderstanding the texture format. Because we know that the screen dimensions are not 256, 256. What is going on here? Vim is freaking out. There we go. My browser just randomly restarted. It's matching the mesh already, yeah. Well, it's matching the target, so it's matching the image, if I'm correct. Hmm. So that's good. We've learned something new about how the render target works. I might easily be getting this wrong. Um, I'm encouraged by the fact that it's black. I don't understand why the image data is not different. There was this weird bug we were looking at the other day. We had to call get mute on the material before it would actually before it would update. Might be compressed or something. You want to access the function, access the image data using the function I linked before. Scrolling up, scrolling up. It's been a long conversation. Oh, image pixel bytes mute. Yes, I remember using that somewhere else. I think you're right. Yeah, so why would accessing the data that way be bad, I wonder? But you're 100% correct. Um, okay, I've used that before. Why have I used that before? Oh, because when we were writing the original terrain destruction, we were accessing the individual pixels as mutable on the terrain image, doing very much the same thing. So yeah, good reminder, good call. So let's go, let pixel equals, or pixels, image, pixel. It'd be a laugh if it was already working and I just hadn't. I think there's a get, isn't there a get pixels as well? Why is my Rust Analyzer not auto-completing? Actually, let's look up the original. Oh, wow. That did not work. It also just doxed me, but it doesn't matter because I am an open book. It's very easy to find my real name. Uh, oh, yeah. You're auto-completing for me. You're my own private Rust Analyzer, but I was just going to look up image docs. Bevy image. And we get pixel bytes mute, pixel data offset. What is that? Compute the byte offset where the data of a specific pixel is stored. Interesting. So all we really need is pixel bytes. A reference to with chords UVAC3. Okay. Where a specific pixel's value is stored. So yeah, you're right. Maybe there's compression or something. Who knows? Pixel bytes. With a specific coordinate. So let's go back 3 0 0 0. Oh, what am I doing? It's all that texture format. The pixel bytes handles whatever store. I gotcha. Yeah. So reading it straight was always going to be a dumb idea. What am I doing? Oh, Jesus. I am losing the plot. This should not be a surprise to anyone. Oh, I see. Um, it's still 0. It's a UVEC3, yeah. And I assume if I pick a random pixel from within this, like say 128, 120, oh, 126. No, that's right. 128, 128. that it will be the same. Yeah. Oh, unless, hang on, you need to go to the end in case it's before and after the render pass, but no. So I'm rendering to an image. The image is showing up as black, as you would expect. But the data, the pixel data on the image is not changing. Now, where am I? That's on the resource. Where am I changing the resource? So the resource is, and we could just query the material, but the resource is here where we set the image handle. We store the image handle on the resource as well as adding it. I mean, for that matter, we could just do. But we still. No, we could do this. Just to be explicit. There's only so many times you can run a program that generates a black square without feeling the futility of life. Oh, God. It's the most scintillating stream to watch. Okay. We're learning. It's good. We're learning. There was a weird behavior about images get mute. No, it was materials get mute, where you had to call it in order to update the texture, but I don't think that's relevant here because we're rendering to an image. I just don't understand why the pixels of the image don't appear to have changed, even though, yeah. Let's take this transform away as well. Access the target from the camera? Eh? To get the data. So the camera has a different copy of the data? Oh my God. But see, I need it to update on the CPU side. That's the whole point. Okay, but yeah, okay, camera. All right, camera. Access it from the camera. So how the hell, if you access camera target, oh. So you think it's keeping its own copy of the image? Hey, it's worth a try at this point. Okay. So we're looking at single camera with render target camera. Images get cam target. Nope, hang on. What is it? Oh, it's probably an option, right? Right, because it's a render target, not a handle. I need into, possibly, it might not go both ways. Handle image from render target. Yeah, okay. So what is in my let handle equals cam target? O possibly? What is an O? Yeah, I was wondering about O. Okay, let's go to render target. Is that what we're dealing with here? Oh, right. Duh. Okay, let's go look at the type. We got image. Yeah, you'd think it would be O. That's weird. Maybe I'd have to do a match because it's an enum, right? So that would be the only way to grab it. It's kind of weird that there's no method for it. Yeah, you got to do a match. Yeah, exactly. So our result is going to be image. And our default result is essentially panic. But what can I do? I don't know. Just a random handle. We could display the green one. No, that's stupid. What can I do? I can't do this because the types will be different. Oh, none. I don't think it. Well, it is an option. I suppose I can make it an option. Yeah, fair enough. And then this is going to be an unwrap. Well, that was fun. Yeah. All right. Let's see what happens there. It is still 0. Hopefully that worked and I'm not crazy. I wish I could tell you it did. Huh. I do not know what's going on here. Hmm. Huh. What else is there to try? We do appear to be rendering the right We're just not rendering it in a way that can be used on the CPU. Runs after the render. I mean, yeah, but would that would that suggest that the image is always being reset to 0 before every render pass? Because I'm not sure I believe that. Like, why would it go back to its initial value and then snap into black and then go back to its initial value? That kind of wouldn't make much sense, I don't think. Unless it reinitializes itself every single time. I mean, if I change it, and actually I shouldn't, well, I shouldn't take the values from the first part of the run. Like, I should always close this, go to the end, and make sure it's still outputting once. But this is a terrible way to debug. This all started because I discovered I couldn't use ordinary collision detection. I had to use pixel-based collision detection in order to make this game. But now I just really want to understand why. It's a curse, I tell you. It's a curse. Okay. What else can I try? I think I will post this updated work as part of my Discord thread. But it's always O, 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 O. Let's go here. And this is a minimum. What is it called? Minimum. What does Stack Overflow call it? Minimum demonstrable, reproducible, minimal repro of what I'm battling. Oh, god damn it. Discord freaking Nitro. How could I reduce all of that? Ah. Maybe I'll put it as a gist. That was that normal map someone sent me. My gists. Minimal repro of image render target issue. Um, the render image appears to work. I just don't understand why all the pixels appear to still be zeroed out. When accessed using get, what does it get, pixel bytes? I don't think it's related to that bug. Author me. Hey Finn, how you doing? Hope your Sunday's going well. I don't think it's related to this. Add it to a mesh material 2D, render it using a mesh 2D, and the fixed update schedule modify it. Yeah, I don't think it's. This is more of a rendering change rather than a pixels change, like a render to image change. Hey, Quellis needs a shout out. Excellent. Huh. Who else is on? We got Settlix. Yay. Bevy Easy Portals, while in 3D, does a bunch of stuff with render targets. Might be overkill as an example worth mentioning. Yeah. Yeah, that is a good point, actually. I mean, we know that what I suspect is that the image rendering part of it is working, but I'm accessing the pixels incorrectly. I think that's what's going on. Maybe the alpha bit is different somehow. I don't know. For a real world implementation, yeah. Well, let's do a quick cruise through. Baby easy portals. Portals are hard things, so anything that makes them easy is good in my book. Oh, where's your GitHub, baby easy portals? Where's your GitHub? If you click the credit at the top, you can go to the repo. Huh. TIL. Okay. Actually, let's look for render target. Yeah. Yes. Render target image, image handle clone. Normalized render target. What is a normalized render target? Oh, so 0 to 1. That's interesting. I'm so tempted to ping Charlotte because they always seem to understand my problems with rendering. But I'm not going to. So that would be rude. They've got enough to do. Normalized render target. Once we have this, we shouldn't need to resolve it down anymore. That's a weird document. Useful when the texture needs to be created outside of Bevy. Huh. Oh, I see. Okay. Yeah, anyways. That's interesting. Binding DST attachment. Order -1. Render target image handle clone. Primary camera clone. So just copying settings. You got to go, hey, thank you so much for your input. I mean, we didn't quite get there, but I learned a lot. So I appreciate that. Okay, so primary camera clone. And thanks for the follow. I see. Okay, but these are very similar settings, so that's good. It doesn't use it's on render layer 0, so that's also interesting. Always love a good Bevy dev stream. Yeah, me too. I'm trying to find more of them. Wait, should I be following you for that matter? Just in case. Okay, now. Always down to chat about Bevy. Absolutely. Nice. Okay. So update transform. I don't think we're going to need. Resize portal images. I'm actually looking for render layers at this point. No use of render layers. Interesting. Oh, that's on mesh picking. Oh, they're both examples. Huh. I guess you would have to be on both layers if you were doing a portal because you'd want to see both images, maybe? Hmm. Hmm. I feel like this is overkill for what I actually need to do, but I'm down the rabbit hole now and I can't stop looking because I want to understand it. Why would the image data still be 0 even if it was being rendered as if it was 1, as if it was like alpha 1? Hmm. I mean, it wouldn't hurt to run it through the LLM just to see if it rings up any out of date information. Let's try it, because sometimes it will show you things that you didn't know about, even if it's full of shit. Let's give it a crack. The following Bevy example appears to render to a target image correctly. However, when the image's pixels are later accessed, they appear to be still the original initialized values. Attempt to explain this. GPU and CPU texture access, timing of access. Check image is trying to read the pixels on the CPU. We're getting the CPU side copy of the texture data. It isn't automatically synchronized with the GPU rendered result, except that it should be, because we're in the retained rendering world, but it doesn't know about the retained rendering world because that was Bevy 15. Missing texture extract. Wait a minute. Isn't there a thing that you pass to force image retention? Something about synchronization? Huh. Missing texture extract. You need to explicitly extract the data from the GPU. Screenshots? Res image render target. What the hell? Extracted screenshot. Is that a thing? No. I think you just made that up. Let's focus on retained rendered worlds and how that might affect us. Entities are no longer despawned at the end of every frame in the render world. Extracted entities with a temporary render entry component will be despawned at the end of frame like before. The entity, the entity identifiers, I forgot about this bit. In the main and extracted version and render world are no longer guaranteed to line up. As a result, all tools to spawn entities with a precise entity ID are in the process of being deprecated and will be removed. Collections that contain references to entity that are extracted into the render world have been changed to contain main entity in order to prevent errors where a render world entity ID is used to look up an item by accident. Custom rendering code may need to be changed to query for main entity. We're not really using entities though, we're using handles. Users who implement their own extraction logic for collections of main world entities should strongly consider extracting into a different collection that uses main entity as a key. Render phases now require specifying both the entity and main entity for a given phase item. What's a phase item? Entity of the render world which will be drawn to a texture or the screen as part of a render phase. Okay. We don't need that. Renderers can now check render visible entities to avoid rendering items that are not visible from a view. Let's look at a few common patterns. Spawning entities in the render world. The extract component plugin automatically sync entities with component to extract. Any code using extract component plugin will not require any changes. So could I use this to use rendered entity and main entity as simple wrappers around entity? Mixing these up can become a real headache and lead to some non-obvious errors. Oh, it's brutal. I wish I understood it. Maybe accessing things in a different schedule could help. A post-rendering schedule, maybe. Potentially. I think I have this image of images or image assets as things that are like constantly changing, but maybe that's not the case. I might update it to have I looked at Bevy image extract? I have not, but maybe I should. Just returning this to its original state. Hey, Lorne, how you doing? Bevy image export. I would expect this to be black, but it's still zeroed out from its initialization. Due to the shader output of that color. Where is my gist? Where is my gist? Edit, edit. Publish a new version. What do we edit just? I haven't done this for ages. Revisions. Edit. What? No. Okay, that's better. All right, Bevy image export. Maybe this will be the solution. Bevy plugin for rendering. Ooh, that's bright. For rendering image sequences. Not this one? You don't expect this to be a full solution? I gotcha. I'm just curious to see anyone that's rendering to images at this point. That's interesting. The problem, as I see it, and I could be explaining this very badly, is that we'd like to have the output of a shader be available as an image over on the CPU side so that it can be used as a source of truth for things like collision detection. And yet, when I try to access the pixels from that image, having rendered it, I think they all appear to still be in their original state. This is the render output. This is what's supposed to be happening. But the pixels do still appear to be zeros, and I don't know why. And it could be that I'm accessing the pixels wrong. It could be that I'm misunderstanding the way the image data works. But I just don't have enough information yet. Loads the image back from the GPU, right? So it's not quite doing what we're doing. Not that that's bad. And I've considered CPU and GPU have different memory. CPU to GPU is kind of slow. GPU to CPU is very slow, right? Yeah. I have seriously considered and probably will look at next doing collision detection on the GPU just to learn it. But I want to understand why the image isn't changing here. It's interesting that here we've got copy destination and copy source. Yeah, but didn't that change when we did retained rendering world? I thought we synced both sides now. Or if I just misunderstood that completely. Let's add back copy source just for the fun of it. Doesn't mean what I think it means. Yeah, fair enough. That would not be at all unusual. Oh, yeah. What is the implication of texture binding? Because they don't use that. Regardless, I would have thought that if an image was rendered to, if the render target was an image, that the image data would be changed on the CPU side, but obviously that's not the case. So maybe that's the final solution, is that it's not supposed to work this way. Retained rendering world just means less work to render each frame. I understood that there was a sync phase each time, but maybe that means something different. I saw a good picture of it. No, that's the old one. Oop-a-doop-a-doo. I saw a good picture one day and now I can't find it. Oh, is it this one? No. Let's look in Discord. The render world is an ECS world. Yeah, so difference between main entity and render entity and all that good shit. Hmm. Anyway, let's not go off on another tangent. So the upshot of it could be that we just don't have access to the image data on the CPU side at all. I see. The render world is entirely CPU side. The render graph, well, maybe that's a misunderstanding too. I don't have access to the textures on the CPU side at all. Yeah, I'm listening to you. I'm just trying to process what that implies. So the fact that I'm rendering to an image actually doesn't really help me that much. Look at nodes RS in Bevy image export. Where's my... Whoa, that's not what I wanted. Where's my GitHub gone? That code is what actually sends the command to the GPU to send the data back, please. Hmm. Okay. GPU image. The GPU representation of an image consisting of the texture, etc. Okay. The code has to be run inside a node on the render graph, and you have to insert that node at the appropriate time in the render graph where your shader is done. Increasingly feels like the right thing to do is do most of the stuff GPU side anyway. And then render context, command encoder. Required to interact with GPU. Render device, right. Okay. What the right thing to do is depends, yeah. Hmm. So rendering to an image was helpful in that we can see how it changes between image targets and, for example, window targets. But it's not helpful in that we still don't have direct access to the data that was generated by the shader. Hmm. Yeah. It's good though, because now we've at least seen the way that the render layers interact, because I didn't understand that before. But using everything as render layer 0 except for the output layers or the destination layers, that was kind of useful. Hmm. Kind of a bummer though. I was kind of hoping we could get that working, but I don't think it's practical. We could use like or we're going to have to use a storage buffer to communicate positions with the shader and do it that way, I think. Hmm. Oh, we got ads. I am going to make a cup of tea while I think about all that. Okay. Now then, let's see. So I think we can safely say that this approach is not going to be useful, although it's pretty interesting. It certainly taught me a lot about rendering. So let's go back here and say it does seem like I'm trying for something that just doesn't work that way. Um, at least not without doing a direct copy from the GPU. So we might shelve this approach. Interesting though, I discovered a lot of concepts I didn't know about, including render layers. Excuse me. Camera, target, and so on. Excuse me. So we need to make resolved. Oh, the upshot is the image data doesn't actually change after the shader runs, even though it appears to, because we are rendering it to the camera by the image, I guess. Okay. I wouldn't be sure this approach isn't useful. What's the goal? I think the approach that I'm doing right now isn't useful because we'd have to do like a synchronized copy every, I'm not even sure how often in order for it to work. I mean, it could work, but the way I'm doing it now, I'm expecting changes to show up in the image just because I'm rendering to the image, which isn't the way it works. um, Although I had this misconception in my brain. Where is my resolved? There we go. You can copy out textures every frame. Yeah. I mean, I could, but I just don't know that that's makes as much sense as potentially the downside of it is that if you do it on the shader, you in a compute shader, you're basically checking every pixel, but which might not be terribly efficient either. It's slow enough you'd never do it by default. Yeah. Fast enough you can use it. I mean, the stupid thing is that this is not going to be a graphically taxing game. it's it's really just a maximum of maybe a couple of hundred characters on a screen, each being collision detected. So given that Bevy ought to be able to handle probably thousands, I don't think that's a concern. But I'm just trying to understand the different ways of going about it. I might spend some more time looking at the export. But I think my question was always, hey, why doesn't this work? And I think we've discovered why it doesn't work. So here what's the setup? Let's go back a step. Actually, let's find where's their GitHub? Where is their GitHub? There. Have you considered just doing your stuff fully CPU? I started that way. Um, and then I went, hey, how do I do this with the GPU just to see what would happen? And now I'm down this rabbit hole. It's not about really necessarily even what's most efficient. It's just making sure that I learn about all these concepts. Bite mark any bit pin. Don't recognize that. Okay, GPU image export source. Extract component. Help someone with modifying Bevy image export to just write to a CPU texture instead of disk, right? 3 Bevy versions ago. The landscape changes. I mean, if I'm going to be doing it in the shader, in the compute shader, I need to be continually passing in the locations of everybody and then checking that against a subset of the texture, basically. Actually, you wouldn't need the locations. You just need the location of their feet most of the time. And they're just looking for collision or looking for alpha, really. And then communicating back. So how does that all work? Let's look at the compute shader examples. No, not the Bevy engine org ones. Compute shader game of life might be an interesting one to look at. And the shader is shader's game of life. That's weird. There it is. Reads the previous frame state from the input texture and writes the new state of each pixel to the output texture. Huh. Right. Two textures are needed. Each pixel of step in. Right. Because it's a state machine, essentially. It's a little more complex than I was hoping for. Actually, it's not as long as I thought. This is neat, but kind of opaque. So I could, for example, in the shader where we get location for cursor position, we compare it to mesh position. So instead of doing that, we could compare it to character position. How does it pass the textures in? I see texture storage 2D, R32 float. Can't get type information on these, can I? Damn. That's annoying. I have a horrible suspicion this is going to be a brilliant white background. Yep. I bet there's no way to change. Oh, hang on. Oh, no, I tried this and it didn't work. God damn it. Hey, it worked that time. All right. Storage texture types support accessing individual texel values without the use of a sampler. Well, I've got a sampler. So would you run a separate compute shader to the mouse shader one that we're using? Or would you pass the values into the fragment shader and do it there? That doesn't make much sense. I wonder if there's any information on general compute shader collision detection. Actually, there was someone that said in Showcase just the other day that they were doing this. Lots of cool stuff happening in Showcase at the moment. So model generation and collision detection system I wrote using compute shaders, pure GPU computation, trigger readback complete to access the structured GPU cache for collision detection. What? Excuse me. Oh, that's right. I couldn't get this to work before and I downloaded it instead. It's pretty cool. Amazing, really. Created a child window within the parent window and rendered a web view. Oh, cool. Huh. That's kind of neat. First iteration of loading landscape and LODs. No texture shaders or other fancy things for now. I don't really understand what I'm looking at there. Is an LOD a load on demand? Guess so. Experimental physics-based character controller with procedural animation that's strongly coupled to the physics. Really like where this is going so far. Level of detail. Huh. Right, so scroll in, scroll out, I guess. Zoom in, zoom out at least. Cute. Oh, that's cool. Is there a stick figure? No. Person? Someone running? That's really awesome. On the walls? Oh, wait, we're supposed to use threads. Mean an error occurred. Please try again later. Ah. Wait, that's not it. I guess this needle thread didn't work. Now it's created one for me. Unicode renderer has some new and exciting bugs to work out. There's replies in the thread already? Oh. Oh well. My Discord must be broken. Wouldn't be the first time. Oh yeah, look at that. The hell is a vest top? Huh? Huh. Cute. It is not uncommon for Discord to break, that's for sure. What? All right. That's enough discording. I don't want the AI response, collision checking and pixel shader. Technically against the terms of service, yeah. Anything that stops them from getting people to pay for Nitro, basically. Well, it's 12 and my brain seems to have run out of steam, which is not at all surprising. So I think we might end up just calling it there. And I'll look into this compute shader stuff more later. Anyway, check out uBlacklist for cleaning up your Google responses. Yeah. Basically, I'm an open book at this point. Sweet. Well, thanks for listening in, and we'll see you guys next time.